So we have a few points here. Some of them are more for discussion. Some are more informative, but of course, all questions and discussion points welcome. Like I just said, the first point, actually, optimization opportunities. I was quite glad that most of these points had actually been raised in previous discussions, but it still would be good to have it, to bring it together and maybe touch some more in depth upon these, because Fortran as a language has a few peculiarities, which some of them can actually be used to very good effect regarding optimization opportunities, and others, well, where we're actually struggling, at least we're struggling still a bit with one very modern language feature, which actually brings some disoptimization to the language. One of the things that was already talked about, and I think Richard, we're already very well on the course there. If not, please say so. There's the vectorized math library support. Paul already sent you some emails on that. So if there's any more questions, please do not hesitate to ask. The other, and of course that would really be a big boost to really have vectorized math libraries in our compiler, or rather use the glibc support that is already there. And there are some things that really can aid optimization in Fortran. Fortran has very many sentences in the standard which says this or that shall. And that puts the blame, if it's not followed, squarely on the programmer. So in other words, it's what C calls undefined behavior. And of course, as with C, we're allowed to use that for optimization. And it's actually supposed to be that way. There are other things which are within constraints. We're actually forced to diagnose. And one of the most important things is that variables really cannot be aliased. And if there's a variable and you do not explicitly mark it as target with a nice round target on its back, it's not possible. And that of course runs a bit counter to what C does, that you can sort of take the address of everything, and if it escapes, then people can do strange things with it. And that is really something that is probably hard to put into the middle end. In a previous session, we already discussed a little bit that this would probably require additional support. So, yeah.
I think a related thing is that Fortran doesn't allow recursion to occur unless you mark a procedure recursive.
Yes, that is true up to, well, Fortran's had recursive procedures up to from Fortran 90 on, but you had to mark them explicitly. From Fortran 2018, the default is actually switched to recursive. There's a new non-recursive keyword. I think that was done because of the co-array stuff, probably, right?
Well, I can't remember exactly what the reason was for using non-recursive, but it could well be that a lot of Fortran programs simply don't use recursion, and it gives additional optimization opportunities.
Yep.
So maybe it's possible to have a switch.
Yeah, we know.
Switch the default.
Yeah, we know. I mean, we have F recursive right now, so that sort of puts everything into recursion, and OpenMP requires that for obvious reasons, and that also causes a lot of old Fortran programs to crash because of limitations due to stack size. So I think we're going to have to put some more work in if we actually change this to the new default, because then I think we will have to put a lot more arrays on the stack. Sorry, not on the stack, on the heap, because the stack will just overflow too fast. So yeah, but yes, non-recursive procedures, subroutines, functions are of course still around, and we could use it. Another interesting thing is the intent of variables that Fortran has. You can mark it as intent in, which means that the routine doesn't change anything, and this is actually caught in the most cases by the compiler. But if the user manages to do it anyway, it's his fault. You have intent out, which means that the value really is undefined on entry. So whatever value it had before, just discard it. And that is something that we could actually use for optimization. I once asked on IRC and was told that, okay, clobbering the variables is the way to go. But so far, I haven't actually been able to find out how to do that. So if anybody in the audience could maybe give me a sort of a hint later which magic incantation to chant or which wand to wave, that would be very good.
For clobbering the Gimplifier, you will find such spots there.
Okay, yeah, I'll.
Expert. It's really like 3 lines of code.
That's what I expected, but I sort of didn't find it. Okay, and you could do it right before a call, because obviously it's not doing there, and also on entry out into the subroutine or function itself, because again, we know there's nothing of value there. And this, of course, could also help in finding some bugs where people actually use the value of an intent out variable, because we do not actually check for all of that at the moment. So it's also useful for finding bugs. Another thing which we also discussed a little bit is the invariance of our do loop variables. So within a do loop, you are not allowed to change the value, period. And we actually catch most of the cases, but not all of them. Because some of them would really have too much false positives. And there's one PR where actually a do loop is slower because we put in a print statement printing that variable like that, where the compiler thinks, they will take the address of something may be wrong. And if we put it in brackets, which sort of means, okay, this is a copy, this is an expression, a different variable is generated, it's actually faster. And of course, this is not really how things should work. The difference is not big. It's a fairly evil test case, I have to admit. But on the whole, it's still something where something's not going right, and I'm not sure what exactly. If it's the escaping pointer or the compiler in some path still thinks, maybe somebody's changing things there. The intent in variables I already briefly touched upon. These don't change. Also, if their address is taken, yes.
So if you have an intent in structure and there's a pointer field in it, does the pointer to data, does that change?
The pointer, the data at the pointer can change, but the pointer cannot change.
Okay.
It just means tree read only on the variable, but usually pass variables by reference. So what the reference points to is also tree read only.
But
yeah.
what that points to is not read only.
If it contains a pointer, yes. But the other thing is, of course, that if it contains an allocatable.
It can't be reallocated.
Yeah, that's right. But we probably have to dig through the standard for that one. Yeah. Another thing is array descriptors. Fortran has the very nice feature that you can actually pass an array, and if it's, as we call it, their assumed shape, all the information about bounds and so on is passed with it. So that is actually very nice for the programmer, because people make far fewer mistakes than before. Because if you look at at a 30-year-old program, it usually had arguments lists about an arm long with 20 or 30 arguments. This array has that dimension, this array has that dimension. And that's really easy to get wrong on long calls. And if you put this down to the modern way, you could probably just compress it to 4 or 5. That's a good thing, of course. The bad thing about this is that, well, for optimization, bad thing is that you can also specify in each and every call a stride. So you're actually not that if the argument that is passed may actually not be contiguous, but it may actually be strided. So let's say the first element, the third element, the fifth element, and so on. And bad thing is, of course, the compiler always has to be correct. So we have to read the stride out of that descriptor and pretend that it's not going to be 1 in 99.9% of the cases. And there is some, and I think there's still an optimization opportunity for IPA there. And I have to say that there's already been, as a resolution of one PR, a great progress. For example, if you have only one single shape of array that you call in your program. Let's say you have a function which deals with a lot of 3 times 3 arrays, and you call that, then a simple test case will already show you that yes, it's going to be inlined, and it's going to be special cased for that array size, which of course for a runtime, I mean, just think of that setting up the descriptor and unpacking it on the other end and so on. What's sometimes lost though is for example, if you call it with different array strides, is that the information that the stride is actually always 1, which is a normal use case, is sometimes lost.
So is the descriptor itself intent in?
Yes.
You're not supposed to, well, you can't change it from Fortran.
I mean, it's an implementation detail, but so the Fortran doesn't reuse descriptors that are passed in for. Maybe it passes them along.
I mean that the compiler could reuse the area that you used for a descriptor for another one. I don't know. That's all the detail of the problem.
Okay.
I think if we pass it along, we would have to look, but we should actually only pass it along to things which also don't change it. Because the thing is that if it's, the question is what argument is it? In most cases, it's just a normal argument, and then it cannot be changed. If you pass an allocatable array to in Fortran parlance, dummy argument with the allocatable attribute, that is, of course, something that we know and also something that we can block, then that can be changed. But that is really a special case. So for normal argument passing, which people...
Well, that's true. Then it
but then it can be derived time with allocatable field.
Yeah, I mean, we could. I mean,
like the stride and the other things apart from the data field are usually not changed.
No, they cannot be. They cannot be changed. And actually, if it's allocatable, then the stride is always 1. So.
Yeah. So what I was thinking is we do have the issue that if you like mark this kind of array intent in, you get the descriptor marked as not being changed, but the data is actually not marked for the optimization as being not changed. So it might be even not true if it's allocatable, and you may get wrong code because of that, and you don't get the optimization on the data. So may it make sense to pass the data pointer separately? So always pass 2 things: the pointers to the descriptor and the pointers to the data. Then we can control each individually. It would of course be an ABI change, but it would remove the indirection.
But another possibility is to just use special attribute on the descriptor, which says this is read only, and what this points is read only or not. And another hint. This is stride, and this is most likely to be 1, and so that, for instance, the vectorizer could choose if it makes sense to vectorize it only with stride 1, then just do it, and that's most likely, and have just a scalar fallback.
Yeah, the thing is, even with an intent out variable, the descriptor doesn't change. It's only actually it's only the data that is pointed to that will change. That's all.
Even if can you have an intent out allocatable thing and
yes.
Yeah,
but
so how does the allocated storage get passed back to?
The nice thing is, if you have an allocatable intent out, the first thing the routine does is to deallocate it. And lazy people like I am actually used it.
Yeah, you know. But so actually, the caller inspects the array descriptor again to get at the allocated storage. So basically, the return is via the descriptor you passed. So
yep.
The descriptor changes.
Yeah. So, but we know. I mean, we know because we can only do this when we have an explicit interface. So we know the calling routine has the allocatable attribute on that argument. We know what we could switch what we're doing there. It would make absolute sense. So yeah, that would be good if we had some way of annotating these fields, definitely. Finally, what we have is do concurrent. That's actually a language construct in which people tell the compiler that yes, everything in this loop is independent from every other iteration. So you can define a local variable there. Well, or you can define a variable there, but you can only use it within the loop. It's undefined on exit. And if it's something different, of course, it's again the programmer's fault. So after we rather recently marked this as IV dep, so which is, I think, more or less what it is. But of course, there's also a question. For example, is there something more that we could actually do with this? Annotate it in some other way that could possibly work together with OpenMP or something like that. I mean, it most probably would just be adding a few lines of code, but I don't know if any of that would actually be useful. So, question to the audience.
Well, for OpenMP, for instance, there are basically two levels. One is the SIMD loop where the user just says there are no backwards dependencies and there can be forward dependencies. So that's the one possibility, and you can also say how many iterations next to each other have this property, and it can be int maximum. And then there is the other possibility, and that's I think do concurrent, and that's the OpenMP5 loop, where you can say basically these are unordered. There are no dependencies between any iterations. You can run them in any order. And the problem with that is we need to be extra careful that we actually just generate the right thing.
So the issue I ran into with the concurrent was that the autopower doesn't do any privatization of locally used variables. So what was easily visible as just in scope inside the loop body at Gimple, this information is easily lost, and I think the OpenMP lowering goes through, or even the Gimplifier goes through great length to try to preserve the private pieces.
If there are explicit clauses, then we have special magic arrays where we index it by this.
So do you do anything special for the OpenMP loop?
I don't do anything yet because it's not implemented. But yes, it's the same thing like do concurrent. Yeah. You will need to be extra careful, write many test cases, and think about it a lot. But yeah, there will be two modes. One of them is the OpenMP SIMD, which allows some dependencies between loops, and the other one is go wild, and there are no dependencies.
Yeah, so do concurrent is actually the go wild construct. Okay, so
I took the liberty, Thomas, of adding one more slide for you.
oh, okay. Thank you very much indeed.
Yes. Now then, maybe since Thomas obviously didn't have the time to look at it, I better just explain what this is. The majority of users of Fortran tend to take spec benchmarks as being false news. The reason for this is obvious, given the commercial interest in getting spec benchmark figures up as high as possible. So what they tend to take as being a good indication are the so-called polyhedron benchmarks. You will see a variety of brands at the top there, and the two to keep your eye on in the third and fourth columns, Gfortran and Intel without the automatic parallelization. There is a tendency for users of Fortran or professional users of Fortran to use Intel in the office and Gfortran at home, and they rely on the fact that they're pretty much the same level of development and also have pretty much the same overall performance if you look down at the geometric mean of performance. Now, what is interesting, and we've been aware of this for quite a long time, was one or two of the test cases in this suite where there's a very substantial disparity between Gfortran's performance and that of Intel. So, for example, if you look at MP prop design, you'll see there's nearly a factor of 3 difference in execution there. This more or less disappears if we link to the Intel library. So we've obviously got some work somewhere in there to do on the library.
Math functions or
So this is a known performance problem for Gfortran. In spite of that, the geometric mean comes out as being pretty good. There's just 1 or 2 such isolated cases. And we've even got 1 or 2 greens, even against parallelized load modules. There's an interesting remark from the polyhedron people themselves, which is that auto-parallelization settings are not used on any other compilers than the Ansoff and Intel, because we found they produce no significant performance benefits in this benchmark set. So there's clearly something that we could be doing there as well. Just flag that up as something which is biased. The Ansoff and the delightful way of setting auto-parallelization, they've got OVE optimization level 5. What for is, I don't likely know. Now, this one is less for discussion and more for just to inform you as to what we're up to. Unfortunately, the originators of Gfortran were working in the day when memory was still an issue. So they sought to make the array descriptor as small as possible. They combined, for example, the rank, type, and kind information in a single integer, with the result, for example, that we couldn't comply until relatively recently with the rank in Fortran going from 7 to 15. We have worked recently on the array descriptor and expanded it to get over those problems and simply ignored memory issues taken by the array descriptor. We are heading towards eventual 2018, F2018 C Fortran intercompatibility or interoperability compliance, which means that we have to change what is called the dimension triplet, which at the moment consists of L-bound, stride, and U-bound, into L-bound and then
the stride measure and extent, which are measured in bytes rather than in words. So this is something we've got to do sometime. The Fortran minus dev branch was set up, must be 5 or 6 years ago now, by Tobias Burness and myself to actually implement this. Christmas before last, we got as far as having it work and execute the test suite, but unfortunately there's still residual divides by element size and multiplies by element size to go from representing the stride to representing the stride measure and back again, and there was a very considerable performance hit. And what is now needed is to go through that branch with a fine-toothed comb and eliminate all those multipliers and divides, in other words, references to stride in various places that appear in the Go. We've been hit by a recent implementation of so-called parameterized derived types that is deficient in that we have discovered via one of the bug reports that this kind of derived type will also need a descriptor in order to carry the information about both the kind and length parameters, so that when, for example, an entity of a parameterized derived type becomes deallocated, that the information about the kind, and perhaps if declared in the entity's declaration, length information remain available to the compiler. And then finally, Tobias Burness proposed a long time since that if we just added a pointer to the V table for class objects, we could tap this onto the array descriptor, and then we'd have an overall single descriptor which covered both arrays, parameterized derived types, or polymorphic objects, or mixtures thereof. So this is something for the long term, and of course it will require substantial changes to the ABI. So if there's not other questions about that, I'll hand over to Nicholas's tutorial.
So could I ask a question, sir, about the performance?
Oh, sure.
Before that, about the very first point. Apologies if there was a couple of minutes about that, but could you summarize what was the resolution about the vector mapping functions, how they would be exposed to Fortran? We discussed it before.
So I discussed it in personal with Fortran forms. So the idea is to have a kind of intrinsic module that
Can be provided by glibc, for example, which would set up everything as required for the middle end to handle the OpenMP mangled glibc mass routines.
Probably similar to the STDC predev or header that's included automatically. But, well, that's just one thing that we need the Fortran to automatically use this module. Another thing is that we need a way to express it in Fortran. So do we support already attributes, and can we extend it to support the SIMD attribute? And the other thing is that because these are C function calling conventions, we probably need to mark it as ISO C. And the front end needs to find out, okay, this function is a built-in, so I changed not just this interface, but also the built-in. We have that in C and C++ as well.
Yeah, so there's of course the details that need to be worked out. So Suze is volunteering to spend some time on this, and of course we are relying on you to help for the Fortran issues we run into.
I don't know. So this is also just to inform you what's going on in the Fortran, in the world of Gfortran at the moment. we have that is Jerry, Thomas, and I have set out to add a new implementation of co-arrays to Fortran based upon pthreads, because at the moment co-arrays are only implemented using MPI or not at all. So we wanted to make it easier to use co-arrays, so actually people start using them. If I have to set up my API, my MPI first, and then my open co-arrays, and then my whatever, it's difficult, and it takes time and effort and so on. And we wanted for people to make it easier to quickly run co-array programs. Co-arrays in Fortran are Fortran is a partition global address space language. So we have this notion of co-arrays, which if you use them in the program, your main program won't be started once, but a number of times, and execute in parallel, either in different processes or different threads or something. And the only things that are shared between those so-called images are the co-arrays, and you can crosswise index them, right? You can access the data from one co-array put in that one image put in one co-array. You can access that from another image. So yeah, we're currently working on that, on the implementation of that. Sadly enough, we need a new interface because there were some decisions made for the MPI version that are not compatible with using pthreads. Especially they use how they use constructors for allocating the arrays, the file constructors they used for allocating the arrays and registering them. So yeah, that's just a quick heads up. So I think you next. I don't know.
Let's see. Just yeah, Nicholas was talking about a new implementation of co-arrays based on pthreads, but we already have an implementation based on MPI, as he said. The problem is only that it's implemented in a library that's not part of the GCC distribution. So a couple of months ago, the person who was leading that effort asked me to treat this external library as if it was a build requirement like GMP or MPFR, so that it could be automatically imported and built. Well, foolishly I said I would do that, but I've never actually looked at how it worked for GMP and MPFR. It's of course more than just picking up the library from a known internet address, a known URL. You also have to have the machinery to build the library. And there's a snag. Originally, the developers that made that library used CMake to build it. So it seems that there is a makefile-based alternative, but I still have to find out whether it's current and how it would be possible to integrate that in the current build setup of GCC, which makes it look like another prerequisite like GMP. It's not a problem of distributing the libcav, the co-array library with Gfortran or GCC, because the license is in that sense compatible with GPL. So this is something I have to work on the coming months.
So is the plan to copy the library into GCC sources, or to just?
Well, I think we'll start to treat it like a prerequisite like the other ones. And then you probably have to, there has to be some magic in the build process that says, oh, okay, you're building Gfortran too. And
So currently, if I build Gfortran and I build libcaf separately, I can use co-arrays, right?
yes.
So it's not a requirement to build this library together with GCC. So why is it desirable to do that?
Oh, we thought it would be
Because you still need MPI,
easier for the.
or
for-
does OpenCore have a pthread implementation?
No.
No. So you still need to build MPI separately.
Yeah, you need an MPI implementation separately.
So I don't see the advantage of building the OpenCore arrays within the GCC build.
Okay, yeah.
Because
Well, maybe testing.
so currently when I build Gfortran and I build OpenCore arrays and I'm using OpenCore arrays and I specify -f core arrays equals lib, then I still need to explicitly link with the core array lib and my MPI library. I'm usually probably using MPI CC or MPI F whatever for all that, or OpenCore array F. Probably they have compiler wrappers, right? So I don't see the advantage of going to all this pain.
Yeah, it was more making it easier for distributors. I mean,
Just help us
yeah,
building an OpenCore array package.
yeah. Perhaps it can be done, but just
But if it's
describing.
more useful to build it separately, then the distribution will have separate package for GCC and a separate package for OpenCore arrays in that case.
Okay, if you think that it's easier if we keep it separate, it's no problem, of course. But then it has to be described somewhere. So that
I try to do the packaging, but I fail to find instructions how to
yeah.
set up the whole triple of things
Okay.
to be able to use them,
Yeah.
and how to verify if I did everything correct.
Yeah.
So
Okay.
just
So
just
I will
make a
start
wiki
with that.
page
Yeah.
how to set up core arrays.
Yeah.
And verify if you succeeded.
Yeah.
In fact, very early on in the discussion, there were worries about maintenance of the OpenCore arrays library. In other words, as they fixed bugs and so on, we'd wind up with an old version of it, and so you'd have to maintain two sources.
Yeah.
So I think perhaps Nicholas's proposal to do a pthreads version, which indeed you can just run out of the box,
Yeah.
that it knows how many threads are available to it on the machine concerned, and then attempts to use them. I think that'd be a good way to get beginners off the
For
ground.
that library, maybe it would make much more sense to put it into
Yeah,
GCC
exactly.
sources, because then you can use it during
Yeah.
testing and.
Put it into the
Yeah.
Gfortran.
There already is in libgfortran a subdirectory caf, because we actually already have a core array implementation, but it only works for a single image. So it's I think a 2000 line NOP datei. So there already is, and the build process for this thing already works.
But of course, the OpenCore array and what Nicholas is doing really has two different target audiences, because the pthread-based version is just for a single computer, desktop or laptop or whatever. An OpenCore array really is for the 10,000 CPU machine. That's for the supercomputer, and that of course has a very heavy footprint.
Other questions about this? Otherwise, we will move on.
No.
I was too fast.
So this is just a final remark on the last one. Yes, indeed. I guess people will start buying AMD-based machines if you do the pthreads version. 64 threads to play with. Right, a very quick run through compliance on both past and future standards. So we're Paul Brook and Andy Vaught set out in the beginning in time for GCC 3.5, I seem to recall, to write a fully compliant F95 compiler with support for the legacy G77 features. This was more or less completed by 2005, although that's a fuzzy 2005. I had a quick look through the change logs for the subsequent years, and there was an exponential decay of associated bugs which went on for another 2 or so years. But basically, it was there by 2005. And as far as I am aware, we don't have any current bugs associated with, other than regressions, of course, associated with Fortran 95. Fortran 2003 has taken us a little bit longer. In fact, I suppose we only achieved something approaching 2003 compliance in 2017 with the rather defective implementation of parameterized derived types that I just described. But all the other stuff, such as polymorphism, submodules, etc., that was all implemented some while ago. We have, as I say, the partial compliance in respect to parameterized derived types, and it is known that finalization doesn't always occur automatically when it should. So, for example, there are 1 or 2 cases where allocation with a source, rather than allocating an object and then filling it afterwards, where the source, if it's a function, the finalization still does not occur. So there are a number of such cases. 2008 compliance is close. That was a rather smaller, there's loads of small bits and pieces were added in F2008. We've still got some funnies with polymorphic assignment, and especially where allocatable components and deferred string lengths are concerned. Richie has made some fairly acid comments on 1 or 2 of the PRs associated with deferred character lengths, where declaration expressions are needed to be added in various places just to ensure that the types are defined. There is a link there to a comparison between all the different brands in respect of their support for 2003, 2008 features. That link is to last year's version. I provided all the information for this year's version, but it has as yet not been posted. You will find that Gfortran is still deficient in several respects in that table, and most of those features have now been added and fixed. 2018 is the primarily awaiting implementation of the Fortran interoperability features, most notably the Cfi Descriptor. I think what we're going to do in the first place is that there are fairly unique circumstances where the Cfi Descriptor is going to be used on the C side. So I think we will wind up using a conversion at the Fortran side into the Cfi Descriptor, so that then the C macros on the other side can make use of the descriptor.
Is this what other compilers are doing?
Yeah.
It must be, yes, because there is.
I know of at least one compiler writer who said, "Well, I don't have all the fields that are in the CFI in my compiler internally, so I have to compute it when I write out the struct."
Certainly the internal representation of the Intel descriptor, the PGI ACA FLang descriptor, is not compatible with the CFI, and so they will have to do a conversion. FLang are engaging in a project called F18, in which the internal representation will be a CFI descriptor. However, they seem to think that they can implement this in 1 year. As far as I'm aware, they have 2 people working on it full time. I think they'll be hard put to do this, particularly since the starting point seems to be a grammar for which Fortran is notoriously resistant. Yeah, so... And Fortran 2020 is on its way.
The discussion about what will be in the next
Yeah.
standard is on its way, or started. Let's put it that way.
I think the key thing which is going to be seen there, which will be the major part of the work that's involved, is some kind of templating. It'll be very much reduced over the C templating, but it's been noted, for example, if you write a module which has one particular type as its main usage, you might want to clone it many times over for different types. And at the moment, the only way you can do that in Fortran is to cut and paste and use generic interfaces. Now, cutting and pasting is fine, but there are various proposals for a simplified templating system which would suit the Fortran world. Whether it'll come to pass or not, I don't know.
As long as it's Turing complete.
Yeah. Well, the interesting thing is that the Steve Lionel of the X of Intel has taken over as being convener of the Working Group 5, and he, of course, is well aware of the costs of features. And he is very much inclined to take the cost-benefit product as being an indicator of whether or not a feature should be included in the standard.
Sorry, just a question. Do the Fortran standards people, do they behave in a similar way as the C++ people, where like a feature has to be prototyped in GC or LVM, in this case Gfortran, before it's ratified?
More aware of the discussion internal than I am.
The way the standards committee looks at this sort of thing is they never will put a feature in the standard that's an exact copy of someone's compiler's idea of it. So there have to be various implementations that might even differ in the exact syntax, and then the committee tries to abstract from that to define a new feature. That of course carries the risk that in the end it turns out to be hard to implement, but because there are various compiler writers on the committee, this risk is not that big. And the committee itself is far, far leaner than the C++ committee. I mean, it's about 10 or a dozen people instead of 80 or 100.
What about the legacy separate? I saw that many legacy features, especially for DEC compatibility, have been added in the past few years. Are other legacy features still welcomed, or is there just focus on the newest standards?
I haven't heard recent requests for legacy features. So perhaps we now have the bunch that are really out in the wild and have to be supported.
Actually, we have a person here who has just been hired to implement legacy features.
Well, it's free software, so you can always buy your own support.
As it happens, the primary demander of legacy features, in particular DEC Fortran features, is also providing Gfortran with them. So there's a satisfactorily closed loop there.
Okay, we have 5 minutes. Let's see what the final sheet says, because it has my name on it. professional support for Gfortran, and I have to thank Paul for bringing that up, but my interpretation of professional is probably slightly different from his. I mean, I don't think that for professionals you have to be paid professionals. I mean, I think that the volunteers that work on Gfortran are professional enough, but they're lacking time, of course. That's a real problem. Now there are various people working for Linux distributors. Is it within the distributors' say view that people get paid to work on the Fortran side of GCC, or is that very hard to do?
So at SUSE, we are trying to carve out some money to pay somebody to do at least part-time Gfortran support as part of working for SUSE. But of course the difficulty is always finding somebody who's already familiar with Gfortran and is not clinging onto the academia.
Okay, so the I make an observation, and Embercosm does work on Fortran, but on the GDB side of it, so GDB Fortran, that there is a gap somewhere. Just down the road is a UK Tier 2 supercomputer centre at Daresbury. Now, they spend millions on their supercomputers, and a significant proportion of what they run is compiled with Gfortran. They spend £600,000 a year just on the electricity for those computers, and you sort of could save quite a lot of that electricity if you invested that in some optimization. So it strikes me that possibly there's a channel through the advocacy side of this, of actually there are people who have a clear commercial reason to pay for some of this work, and maybe we need to think about how to boost our advocacy.
I've written several times to EPSERC and had no reply to my letters, I must say.
Find out who pays the electricity bill.
Yeah. Okay, any other questions about this?
Just a remark also, indirectly, I've tried to persuade US DOE to come up with some money, and they will simply not have anything to do with funding a GNU project, period.
Fascinating. That's it? Okay, thank you very much.